Hey guys! Welcome back to my YouTube channel. So for this week, we are going to do a revision. So I'm going to revise chapter 1 until chapter 3. So altogether, we have 12 different questions that will cover these chapters. So I'm going to explain step by step how you should tackle all these questions so that it might help you in your test 1 or even final examination. So let's get started. We shall start with question number 1. A balloon is filled with helium gas at pressure of 1.1 times 10 to the power of 5 Pascal with a temperature and volume of 25 degrees Celsius and 6.5 times 10 to the power of 4 centimeter cubes respectively. Determine the number of gas atom in the balloon. So the first thing that you need to do with this question is that you need to check on the unit given in the question. So the unit for pressure, temperature and also volume are in Pascal, degree Celsius and also centimeter cube. Therefore, you need to convert all this unit to the correct unit, which is atm, Kelvin and also liter. So we are going to do that with converting the pressure. So given to you, the pressure is equivalent to 1.1 times 10 to the power of 5 Pascal. So if you can see, 1.013 times 10 to the power of 5 Pascal is actually equivalent to 1 atm. Therefore, because the value in the question given to you is 1.1 times 10 to the power of 5 Pascal, so you should do 1 over this one, 1.013 times 10 to the power of 5. So you need to times the value from the question given to you, which is 1.1 times 10 to the power of 5. Therefore, you should get, because I'm going to divide this one first, you should get 9.8717 times 10 to the power of negative 6 times this value, 1.1 times 10 to the power of 5. Therefore, you should get the pressure should be equivalent to 1.0859 atm. Okay, that's the first one. And then we are going to move on to the temperature. Given to you in the question, the temperature is at 25 degrees Celsius. So you want to convert it to Kelvin. So just do 25 plus 273. You should get equivalent to 298 Kelvin. Alright, let's move on to the volume. So the volume given to you in this question is in centimeter cube. So it is 6.5 times 10 to the power of 4 centimeter cube. So you are going to convert it to liter. So centimeter cube is same as milliliter. So 1 milliliter is 1 liter is equivalent to 1000 milliliter. So in this case, because you need to convert to liter, so you just have to divide it with 1000. Therefore, you should get 65 liter. So these are the three main things that you need to do before you can proceed with the calculation for this question. So from the calculation that we have done just now, so we will have the pressure is equivalent to 1.0859 atm, and then the temperature is equivalent to 298 Kelvin, and the volume is 65 liter. So in the question, you were asked to calculate how much atom. So the only thing that you can use to calculate how much atom is by knowing the number of mole. So in gas law, the one and only formula that can help you to get the number of mole of a gas is actually by using the ideal gas law formula, which is equivalent to PV equivalent to nRT. Alright, so since we already converted all of this in the correct unit, so we just need to plug in all these values so that we can get the value of N. So your P is 1.0859, your V is 65, equivalent to N. So R is the constant value 0.0821, and your T is 298 Kelvin. Alright, from here you should get N is equivalent to 70.5835 divided by 24.4658. Therefore, you should get your N equivalent to 2.8850 mole. Okay. This is not the end of the calculation for this question. So the question asks how much atom, right? So 1 mole of a gas is equivalent to 6.02 times 10 to the power of 23 atom. Okay, this is actually a constant value. This is a constant value that you need to know, which is equivalent to the Avogadro number. Alright, so since you have this much mole, so you have this much mole of gas, so you're just going to convert it. So 2.8850 mole. So how much atom is it? So just 6.02 times 10 to the power of 23 times this value, 2.8850. So therefore we should get 1.7368 times 10 to the power of 24 atom of helium. Right, so this is the final answer for the first question. Moving on to question number 2. A balloon can hold 100 liters of air. If the balloon were to blow up with 3 moles of oxygen gas at a pressure of 1 atm inside it, determine the temperature of the balloon. So since you were given the value for the volume, the number of mole, and also the pressure, and you were asked to calculate the temperature of the balloon, it means that you need to use the ideal gas law formula. So the ideal gas law is equivalent to BV equivalent to nRT, and T is the thing that you were asked to calculate. So from the question, we can see that the pressure is 1 atm, and the volume is already in liter, which is 100. And then the N, it says that it will blow up at 3 moles, so the N will be 3. The value of R is a constant value, which is 0.0821. Therefore, you can calculate the value of T. So from here, you can say that 100 is equivalent to 0.2463 T. So T is equivalent to 100 divided by 0.2463. So you should get T equivalent to 406.0089 Kelvin. So, but if you look back at the question, it didn't state at what unit that the temperature should be. So just in case, if the marks in the test question or the marks in the final exam question is more than what you expect, you should get, means that you were asked to convert it back to degrees Celsius. So for that, you just need to do 406.0089 minus 273. So you shall get 133.0089 degrees Celsius. So yeah, that's the way you should answer question number 2.